Hello and welcome to Sudoku. Here is a Sudoku puzzle by my good friend Philipp Blume, also known as Glam Hippo, which was featured in the latest German Sudoku Championship. It was in round 3 and it was the highest pointer of the whole championship. It's called XY differences Sudoku, and this variant was invented by Philipp Blume. And there are a number of practice puzzles on Logic Masters Deutschland, and I practiced this genre a lot, and I broke the puzzle during the championship, which was quite, sad, let's say. So, what is the rule? Well, whenever you get a diamond here between two cells, it means that the difference between these two cells is equal to the first number in the corresponding row if the cells are linked or horizontally, or if the cells are linked vertically by the diamond symbol, then the difference is equal to the digit on top of the column. And, very important, all possible symbols are given, meaning that the difference between these two cells is not equal to this digit. And that's all we've got to solve this. So, where can we begin? These alignments are very important because to have such an alignment of 3 digits, it means that the difference here can't be too big. It couldn't be 5, for example. If you take 1 plus 5, that's 6, plus 5, that's 11. This is too much, so 5 is too big. 4 would work with 1, 5, and 9, but it wouldn't work for a second alignment. So it can't be 4, and it can't be 3 because there's a 3 here, so this one has to be 1 or 2. And the fact that we have a 5 here separated from some digit by a diamond means that this difference can't be too big either. Namely, it can't be more than 4. 4, if this is 1 or 9, then this is 4, and it can't be more. So this has to be 1, 2, or 4. And that's it for the moment, I think. Another important stuff is where can 9 go on this row? Obviously, it won't go there. It won't go here because this difference can't be 9. It could go here, and it could go here. So the possible positions for 9 on first row are those. But if 9 goes there, then the difference here will be 8 or 7. And 8 wouldn't work here, because then those two digits should be 1 and 9, and those should be 1 and 9 as well. But 7 would seem to work with 1 and 9 somewhere, and 2 with 1 and 8 somewhere, and 2 and 9 somewhere. No, actually it wouldn't work because 9 couldn't be here because of those diamonds. It couldn't be here. It couldn't be here, and it couldn't be here because of this 9. So 7 wouldn't work either. Which means that 9 can't go here, and 9 has to go into this cell. And we've noticed that this can't be 7 or 8. And now we know it can't be 6 because otherwise there would be a symbol here. And it can't be 5, so it has to be 1, 2, or 4. And we get a triple. Note that 1 here wouldn't work because then this would be 2, and this difference of 1 wouldn't be achieved, as 1 and 3 are not in this cell. So this is not 1. If this is 2, then this is 1 and this has to be 3, so this is 4. We've ruled out all other values. And we get a 1-2 pair here, and because of this 4, this is either 5 or 6. And 8 does not go here, because there would be a diamond here. So this is 5, 6 or 7. And there's an 8 somewhere in one of these two cells. And we now know that both differences here are 4. And we can't have 5, so we can't have 1 or 9 there. So 9 has to go here or there. And both are possible because there are no diamonds in the corresponding rows. And one can't be here. One could be here. And one could be here. So I used the corner notation for the row. And 8 won't be in those cells either, and 8 won't be here. So 8 has to go here or there, and we get an 8-9 pair. And this is a 1. Now those pairs will be 3-7 somewhere and 2-6 on the other domino. Now this should be a small digit because of that, so this will be 2 or 3 and 6 or 7 here. Oh, but 7 won't work because only 2 pairs can have 7 as a difference, and there are 3 pairs here. So this is 6, this is 2, and we get 3 and 7 here. So the 3 pairs are 1, 7, 2, 8, and 3, 9. And this leaves behind 4 and 5. 5 is not here, it's there. With 2 and 8 because of this diamond and this 3, and we put 4 here. Let's have a look at this. This is 1 or 2. If this is 1, then this has to be 6. If this is 2, then this has to be 3 or 7. And so all of these must go into those dominoes. This 2 says that this is not 2 and 8. Not sure I can deduce anything else. But this 2 is interesting. There's a sequence here. It could be 4, 6, and 8. In any order. Or it could be 3 odd digits without the 5 here. But is it the right place to look? Something interesting here. 9 wouldn't go here because 9 should be between 2 numbers here, and that won't happen. But 3 is very suspicious as well. Well, with the 1 we could have 3, 2 and 4. Not so suspicious after all. Note that 5 doesn't go here because of the 9 and there's no symbol. So this is 6, 7 or 8. Not sure where to look. This 7, well, this number here is interesting because of this symbol. If this is 7, then this has to be 1 and 8. 8 won't go here because it would put a 2 here, repeating these 2. So it would be 8 and 1 and 7. So 7 makes these 8, 1, 7. Sorry. Let's have a real look at it. So it would be 1, 8, 7, 9 here, 8 there, and it seems to work. Yes, that's a 3, that's a 7. It really seems to work. Oh, but then, what would this be? It wouldn't be 8. This should be 5 or 6, and this, and 5 would, oh sorry, there's a 2 here, so 2 won't go here, so 5 wouldn't work here, so we would get 6, 5, 8, 1, and this seems to work very well. So that's not so interesting. I'm looking for hypotheses, for assumptions that would break the puzzles. So that is not useful. But should I have another look at this? So 4, 6, and 8 looks somewhat promising. What about other digits? 9 wouldn't go here. 7 wouldn't work because it would mean a 5 here. 5 won't work. 3 would put a 5 here, so it wouldn't work. So only 1, 3, 7 would work. One, 3, 5, sorry. So there are not that many options. This is either 4, 6, 8 in your orientation, or 1, 3, 5 in this order. And anyway, there's a 5 in one of these 2 cells. And in this case, as we know that 4 is not here, because otherwise there would be a symbol here, and 4 is not here, 4 would have to go here. And then what? 9 is not here, so 9 would be in one of those cells. And this would not be 7, because otherwise there would be a symbol here. So not 7, not 9. This would be not 6, this would be 8. And then 6, 7, and 9. 7 and 9 can't be next to each other because there's no symbol. So 7 has to go here, and 6 there, and 9 there. and it seems to work. But then 1 and 3 here can only be 2 and 8. Oh, that's a 9. So this one has to be 1 and 7. Oh, and then it doesn't work anymore, because then we need a 9 here and a 3, because of this 6 and the 3 contradict each other. Well, so not sure that was intended, but that's an elimination. And now I know that this is 4, 6, 8, with a 6 in the middle, 4 and 8 surrounding. And now this is not 6, so up there I get a 2, because the difference here is 2, and here this is a 5. What next? I still need to place a 5 on this row, and 5 goes here. And 3, 7, and 9. As I mentioned earlier, 7 and 9 can't be next to each other without a symbol. So 7 is here. 9 is here. Oh, sorry. I forgot about 1. I still need 1, 3, 7, and 9. That's not 3. So it has to be 1, 7, or 9. And we have 2 sets of consecutive digits here. One is not here, so this is 3, 7, or 9. Which means that this is an even digit, and it's not 4 or 6, so it has to be 2 or 8. And note that 3 and 2 would make this a 1, which would break. So this is an 8, this is 7 or 9. And note that both options remove 7 from this cell. This is now a 3. And 7 and 9 can't be both here, so this is a 1. And the other 7 or 9. Because of this 6, this is a 2. I get another 7 or 9 here. These are consecutive without S. And I need another difference of 2 here. It won't use 1. It can still be 6, 8, or 7, 9. Here, what are the options? I know 5 must be somewhere here. I could have 5, 4, 3, or 5 here, and 2, 3, 4. But I could never have 6 on this Renban line, because 6 would be next to a 5, and 5 or to a 7. 6 wouldn't be next to a 7. 7 is here. So it would be 6, 5, and 4, and 5 would be here. So 6 is not here. It has to go here or there. And anyway, those digits are 6, 7, and 9, and 6 can't be next to 7. So those digits must be 6 and 9. And 7 is here. Oh, sorry. That was a mistake. Oh, but I know that 6 is not here because of this 5 and the lack of symbol. So this is 7 or 9, 6 is there, and now because there's no symbol here, this has to be a 9, this is a 7, and this is a 7, and this is a 7 as well. I still need to place 3 and 7 somewhere, not here, so 3 and 7 go here. And those are 1 and 9, and because of this 9, we get 1 here, 9 there. Now, this can't be 7, because then this would be 3 and this would be 10. So this one is 6. And the puzzle breaks because none of those values will work for that. Oh, okay. I see where I went wrong. Wow, this is spectacular. So 7 is here with 1. And 3 and 9 there. Wow, this was spectacular mistake. Well, typical canard mistake. Okay, so now this this could be 7. 7, 1, and 8. Or 6, 1 and 7. No, oh. 7 is here, so this is not 7, but we could still have 6, 7 and 1, or 7, 1 and 8. So this is 1 or 8. And now this could be 8, 8, 1 and 9. Would it work? 8 here, 1, 9, 7, that's an 8, that's a 1, and a 6 here. That would totally work. So not that. Oh. I must try something else. What should I look? Where should I look? Would 7 work? 7 here be 1, 8, 1, 7, and 6. And now would 6 work here? If I put 6 here, then this is 7, this is 1, this is 8, this is 7, this is 1. And it all seems to work. Bobbins. So no immediate contradiction here. But, oh, that's what I missed. Because of this 9, this can't be 1 and 9, so the difference here can't be 8, and 8 has to go here. So now I know that this is 1, this is 7, this is 9, that's 8, that's 1, and that's 6, and this is 7. And there's an 8 here, a 4 there, 8 here. Now it's working. And this 7 is the difference here. 9 is not available, so they have to be 1 and 8 in some order. Here I need 1, 4, and 2. This is not 1. And And this one is not 4 because of this 3. That would put a symbol here. And this is 1, 2, or 4. And 8 goes there and 3 there because of this 8. Now the remaining digits in this column are 2, 3, and 4. This is not 4 and it's not 3 because of the 6, so this one is a 2. And this 3, 4 pair makes this a 7, this a 3. I need a 5 here and it's not here because of this 3. That's 5 and 7 and 2 and 6. This 7 makes this another 1 or 8, and now that's a 2, that's a 1, that's not a 1. Progress. 5, 5, I get a 5 here. 5 and 8 would make a difference of 3, so 8 is ruled out. I need a 9 somewhere. Oh, sorry, because of this diamond, this is 4 or 6, but there's a 6 here. So that's a 4. We get the 2 and 4 at the bottom. 3 and 6 here. This row needs a 2. It's not here, it's there. This row also needs a 7 and a 6. And of course, these are not 3 and 6, these are 3 and 5. In typical canard fashion. 4 and 9 there. 6 and 8 here. Now, because of this 3, this can't be a 6, or there would be a symbol. And this can't be a 9, or there would be a symbol here. Now we need 3, 6, and 7. 7 here, there's a 7 there, and a 9 because of the symbol. 3 and 6. 4 and 8. Because of Sudoku and because of this symbol. So now this is a 5 and that's a 2. I still need a 1 on this row. It's not here, it's there. And the end should be plain Sudoku. Of course, I overlooked this given digit a long time ago. This 4 gives that. And the last digits are here. That's a 4. And I think I didn't break it in the end. And this finishes the solve of this tricky puzzle, challenging puzzle by Philipp Blume. And I know that Philipp watches my videos, especially my videos of his puzzles. So my question is, did I really need that long attempt here, that long experiment, or probably there was something less time consuming, less look ahead-ish type of deduction? Well, thanks for watching and see you soon on Sudoku.